Good morning, students. Today we will start the topic named current electricity from physics 2. In current electricity, let us study the first definition of current. Define current and state its unit. The question is in front of you. Electric current is nothing but what flow of charge. What is charge here? Charge here it is what? Electron. So what is the definition of electric current? Definition of electric current is rate of flow of electric charges through a conductor, because current is flowing through the conductor. So rate means what? The total charge flowing per unit time. That is called rate of flow of electric charges through a conductor is called electric current. Mathematically it is written as I equals to Q upon T, where Q is charge in the what? Coulomb. Unit of charge is what? Coulomb. T is a time in seconds. SI unit of current is what? Ampere. Symbolically it is represented by capital A. The smaller units you will find in most of the numericals are milliampere and microampere. 1 milliampere is equals to 10 raised to minus 3 ampere. Remember that, student, because you have to use the value of current in ampere only in numerical, not in milliampere. Similarly for microampere also, if the current value is given in microampere, you have to convert it into what? Ampere. So 1 microampere is equals to 10 raised to minus 6 ampere. But student, what is exactly we are going to study in this topic? The first subtopic in this topic is what? Kirchhoffs law. Kirchhoffs law, there are two types of law we are going to study further. The first law of Kirchhoff is called Kirchhoff's current law. The examiner will ask, state and define Kirchhoff's current law. The question will be like this: state and explain Kirchhoff's current law. It states that, before explanation, let me give the circuit diagram, because it's a current electricity. The topic is from electronics. That's why we have to take the help of circuit diagram. So let us draw the one circuit diagram. Kirchhoff's current law states that, I will give the statement afterwards. First let me explain by the circuit diagram. Consider a point. Let us give the name O. Suppose this point is connected to one of the wire having resistor. Since this is electronic circuit, it is connected to the another wire. There is a one more wire I am going to consider. One more wire I am going to consider. One more. Consider a junction named O connected to what? 5 wires. Wire number 1, 2, 3, 4, 5. Through wire 1, say current I1 is what? Flowing. Through wire 2, say current I2 is flowing. We observe that current I1 arrow, from the arrow we observe that current I1 and I2 both are flowing towards the junction O. Let us consider the current through another 3 wires. In wire 3, current I3 is flowing. In wire 4, current I4 is flowing. And in wire 5, current I5 is flowing. And we observe that I3, I4 and I5 are moving away from the junction O. Now Kirchhoff's statement will come in front of us. It states that, but before that, let me give the sign convention for current flowing towards and flowing away. So let me give the sign convention. If current is flowing towards the junction, then those current are considered to be positive. And the current moving away from the junction are considered to be negative. Then Kirchhoffs current law states that algebraic sum of electric current, algebraic sum of, this sign represents what? Summation. Algebraic sum of electric current at a junction O, at any junction O, is always equals to what? 0. This is what this is mathematically representation of the Kirchhoff's current law. But now I told you, towards the junction, current flowing towards the junction is said to be positive. Current moving away from the junction is said to be negative. So here, which currents are flowing towards the junction, students? I1 and I2. I1 and I2. So I am going to consider those currents are what? Positive. And which currents are flowing away from the junction, students? I3, I4 and I5. I3, I4 and I5. That's why we are going to take those currents are what? Negative. This is called statement. Algebraic sum of electric current at a junction is always equals to what? 0. But this statement can be revised in a new format if I use mathematical concept. That mathematical concept is what? If negative currents, if I shift it towards the right hand side, the negative currents become what? Positive currents. So another statement of Kirchhoff's current law is the sum of electric currents towards the junction is always equals to sum of electric currents away from the junction. What is the statement, students? The sum of electric currents towards the junction, because I1 and I2 are flowing towards the junction. The sum of electric currents flowing towards the junction is always equals to sum of electric currents away from the junction. And here we observe that I3, I4 and I5 are moving away from the junction. So students, this is a Kirchhoff's current law. Kirchhoff's current law can be stated as Kirchhoff's first law. This is explanation. But students, you need to understand how to write the answer. So answer format I have written. So statement I have mentioned here. There are two types of statement. There are two format. You can write either this way or this way. Circuit diagram, sign convention, then explanation. So students, for the circuit diagram, we observe that I1 and I2 are moving towards the junction. Towards the junction, the currents are I1, I2. And moving away from the junction, the currents are I3, I4, I5. This is according to Kirchhoff's current law. The statement I have provided in mathematical format. Then the another format. The students, the last point from this expression, mathematical expression, we said that KCL is based on the law of conservation of charge. The students, hope you understand the Kirchhoff's current law. But students, now we will do we will solve one numerical based on Kirchhoff's current law. So let us take the one example. Example is like this. In an electric circuit, the current 2 ampere, in an electric circuit, the current 2 ampere, 1.5 ampere and 3 ampere flow towards the junction. So now students, for our understanding, we will draw the circuit diagram. Let me complete a question first. While the current of magnitude 2.5 ampere and an unknown current leave the junction, find the magnitude of the unknown current. So from this question, we understood we have to consider one junction, say point O. From this numerical, 2 ampere, 1.5 ampere and 3 ampere flowing towards the junction. So we will draw 3 wires in which current of 2 ampere, current of 1.5 ampere, current of 3 ampere. 3 currents are flowing towards the junction. And the current 2.5 ampere, and there is a one more current whose value I don't know. Let unknown current be what? I, whose value we have to find out. So now I'm going to solve this numerical.